Welcome to ANS Solver question 11. The table shows the first 5 terms of sequence A and B. Complete the table for the 6th term of each sequence. Okay, so as you can see over here, the sequence A first has a difference of 6, then has a difference of 10, then 14, then 18. Now it will be a difference of 22. So therefore the 6th term would be 77. Now let's move on to sequence B. 1, 3, 9, 27, 81. As you can see, in this case I won't be taking the common difference. It should strike you immediately that it's a geometric sequence, which means that the common ratio is 3, which means that when you divide the second term by the first term, or the fourth term by the third term, or the third term by the second term, you will get the same ratio of 3. And therefore, to find the 6th term of sequence B, all you need to do is 81 multiplied by 3, which will give you 243. Now let's move on to part A2. Find the nth term of both the sequences. Okay, so the sequence A is 7, 13, 23, 37, 55 and 77. The difference, as we already calculated, is 6, 10, 14, 18, 22, and since it's not same yet, we will find a second difference. So that is 4, 4, 4 and 4. Now you can see that the common difference is the same, proving that it is a quadratic sequence because we found the difference in the second time. So if we find the common difference in the third time that you find the difference, then it's a cubic sequence. But in this case it's a quadratic sequence, so let's start with that. So for the quadratic sequence is written in the form an square plus bn plus c. So let's find the a term first. So the a term is 2a is equal to the first term of the last row, that is 4. So therefore we know that a is equal to 2 because when you move the 2 to the other side, multiplication becomes division when you move it from one side of the equation to the other. So 4 divided by 2 is equal to 2. Now let's find the value of b. So how we do that is you can use the formula 3a plus b is equal to the first number in the second line, that is 6 in this case. So if we use 6, we can substitute the value of a and find the value of b. So 3 times 2 is 6, and therefore the value of b will be 0 because when you move positive to the other side of the equation, it becomes negative, and 6 minus 6 will give you 0. Now let's find the value of c, and how you do that is you use the formula a plus b plus c is equal to the first term of the sequence, that is 7 in this case. So you know the value of a, that is 2, plus the value of b, that is 0, plus c is equal to 7. So we can move the 2 to the other side of the equation. Positive becomes negative when you move it from one side of the equation to the other. So c is equal to 7 minus 2, therefore c is equal to 5. So now we can rewrite our nth term as 2n square plus 5, because the value of b is 0, so 0 into any number will be 0, so 0 into n is 0, therefore we don't write the second term of the quadratic sequence. Now let's move on to sequence b. 1, 3, 9, 27, 81, 243. 3, 9, 27, 81. So as we have found out that the common ratio is 3, and we know the formula is a, which is the first term, multiplied by the common ratio raised to n minus 1. So let's just go ahead and substitute the values. So we know A is 1 multiplied by R, which is 3 raised to n minus 1. Now 1 into any number will give you the same number, so we don't need to write the 1. So therefore your final answer will be 3 raised to n minus 1 for part A to B. Now let's move on to part B. The nth term of another sequence is 4n square plus n plus 3. Find the second term. So to find the second term, all you need to do is substitute 2 as the n value. So how you can do that is so you substitute 2 instead of n. So 4 multiplied by 2 square plus 2 plus 3. So 4 multiplied by 2 square, which is 4. So 4 multiplied by 4 is 16 plus 2 plus 3, which would leave us with our final answer for part B1 as 21. Now let's move on to part B2. So when they are asking you the value of n when the nth term is 498. So basically in this case what we have to do is they are giving us the term and we need to find which term it is. So we need to equate 498 to the nth term. So 4n square plus n plus 3 is equal to 498, and therefore you can move the 498 to the other side of the equation. Positive becomes negative when you move it from one side of the equation to the other. So 4n square plus n minus 495, because positive 3 minus 498 will give you a negative 495 is equal to 0. Now your first step to solving a question like this should be multiplying the last term, that is negative 495, by 4, which will give you 1980, and then you should be finding factors of 1980 that will have a difference of 1, because this middle term is only n and the coefficient of n is 1. Therefore you need to find factors with the difference 1, and therefore that will be 44 and 45. So if you multiply 44 into 45, you will get 1980. So you can write 4n square. Now 44 is easier to deal with 4n square because you can remove 11n common. So 44n square minus 44n plus 45n, because we need a difference of positive 1. So therefore we keep the smaller number as negative and the bigger number as positive. Minus 495 is equal to 0. Now all you need to do is factorize by grouping together two of the values. So we group together 4n square and minus 44n. Now the common terms in there is 11n. So we can remove, my bad, not 11n, 4n. So if we remove 4n common, we are left with n minus 11 plus, if we remove 495 divided by 45, if we remove 45 common, we are left with n minus 11 again. So you need to check that your two brackets have the same expression, in this case n minus 11, then only you will know that you are solving this correctly. So equals to 0. Now you write 4n and 45 as one bracket and n minus 11 as the other. So you write 4n plus 45 multiplied by n minus 11, which equals 0. So now we know that if you solve for the first bracket, you'll get a negative answer. Therefore this can't be the answer, because we can't have a negative term. Therefore we use the n minus 11. So n minus 11 is equal to 0, and if you move the 11 to the other side, negative becomes positive, so n is equal to 0 plus 11, which is 11, or the 11th term. And therefore this is your final answer for part B2.